Greetings folks and welcome to the Electromaker Show. This is your midweek roundup of all things Maker and embedded and lovely, and I'm so happy I'm finally able to record this show. This was supposed to come out last week, but unfortunately I got back from the UK, I had a short holiday, and I lost my voice completely, which is not ideal. However, the project that we're going to be talking about today inspired me to finally get my head around the Zephyr RTOS, which is much more than just a real-time operating system, and it also uses the nRF7002 which is the Arduino Shield version of Nordic's Wi-Fi 6 IC, and if you remember, the one we decided to give away, and on last week's show we started the contest. So we'll be announcing the winner of that contest, along with looking at Eli Hughes' incredible project, which is a guitar pickguard, which does a lot more than just a pickguard. This is a full DSP machine, one he has already made before and is making a second iteration of. So we're going to be looking at that and a lot more stuff, so I guess we really have to get on with the show. We're going to begin the show today, and in fact probably spend most of today's show talking about the Guitar Actiuve Pickguard version 2. This is a project from Eli Hughes, who is a self-described and accurately described full-stack embedded developer, and just seems like a thoroughly lovely bloke. I'd love to have him on the show sometime to chat about this project and various other things. He is an advocate of Zephyr and a long-time hardware hacker, and someone who is very knowledgeable, and to my absolute joy is a musician and someone who studied music and acoustics as well, and uses his embedded knowledge in music. And any of you who've watched the Electromaker Show for some time will know that this is exactly the kind of thing that excites me the most, which is why I'm so very glad that this project has landed on our table. So the Actiuve Pickguard version 2 builds upon the version 1, strangely enough, of the Actiuve Pickguard. Rather than me go through it, maybe I should let Eli explain it in his own words.
Hello, my name is Eli Hughes, and my project for the Kinetis Make It Challenge was a guitar Actiuve Pickguard. The Actiuve Pickguard is a custom circuit board that replaces a traditional pickguard that integrates a Kinetis K40 device. The K40 microprocessor samples a set of Ghost piezoelectric pickups, does onboard signal processing using the SimSys DSP libraries from ARM, and outputs the signal over a Cat6 Ethernet cable. Some other cool features: it has a built-in OS JTAG debugger, so we can do code development, and it also uses the TouchSense inputs for a really cool user interface. So let's check out some of the tones. So that's an acoustic type sound. Let's try a jazzy tone. Lastly, we can simulate a tube overdrive effect with some other filters and some lookup tables. So what's cool about the Kinetis series is that it integrates all the features I needed for this entire project on a single chip. Thanks for your time.
Now, I could wax lyrical about how awesome this first iteration of it was, but that's not really what we're here for. But to understand how this is going to then be incorporated into the new NXP development board that Eli has come up with, the Super Monkey, which is a very awesome thing we're going to talk about, and the nRF7002 which is of course the Wi-Fi 6 IC that's going to be incorporated into it as well, and these beautiful renders, we'll get onto those too. To understand how we're going to get there, let's just take a quick look at this circuit board, which is a beautiful thing in and of itself, and talk about how the guitar works. Just before we do, by the way, it is worth pointing out that this video was shot 4 weeks after the proposal was accepted. That is 4 weeks after Eli said, here's what I think I would do with it for this competition. They said, yes, okay, do it. And in that 4 weeks, he got this custom PCB put together and did all the DSP in order to have this work the way that it did in the video. And as I maybe mentioned earlier, this is not an audio cable. This is a Cat5 cable. This is an Ethernet cable. And it is transmitting digital audio data, but not actual audio. And in order to understand as we go further in the video, let's just use this PCB as a quick reference point to talk about what is going on here. So the basic flow of the guitar is the audio is picked up by piezo pickups just here, and if you're interested in why he's using piezo pickups rather than the usual magnetic bridge pickups, this video down here is fantastic. The Actiuve Pickguard deep dive. It is a deep dive, but it's only 15 minutes long. It tells you the good reason for using the kind of pickups that he has, also how he integrated it into the circuit board. There's a block diagram of what's happening up here too. So yeah, I highly advise watching this. But yes, the audio comes in and the DSP happens on chip. This is anything you want it to be. In the case of the video, as you saw, it was an acoustic kind of sound, an electric kind of sound. I'm sure if you had more time, you would have made a lot more interesting sounds. The beauty of digital signal processing is that, yes, you can make beautiful sounding, authentic sounding amp models. This is what Line 6 have been doing for years, for example, but you can also do whatever you want. But here's the really interesting part. This is a Cat6 connector. I may have said Cat5 before. It's a Cat6, it's a Cat6 cable that connects to it. The DAC, the digital to analog converter on the MCU, gives out a balanced audio line, right? And that is also integrated into the Cat6, and at the other end you could make a Cat6 to just audio converter if you wanted to plug it into an amplifier, and it would just work like a normal guitar. But it is also sending out that data via the same Cat6 cable using the AES3 protocol. Now, AES3 is a digital audio data transmission protocol. Protocol might not be the right word. I'm not going to pretend that I understand it from the top to the bottom. It is something I have had hands-on experience with. From what I understand, it is a fairly ad hoc and yet industry standard way of transmitting digital audio data from one thing to another. You don't have to worry about converting that digital audio into the analog realm and back again. It is something that works multiple speeds. I think you can send it over fiber optics and even balanced and unbalanced cables. It's very broad. And one of the beautiful things about it is that it is just a stream of audio data. You can do whatever you want with that. You can just, as it is done in this example here, send it along that cable to the other end where you have an AES3 decoder, which that turns it back into audio again. And as it mentions here somewhere, he created his own thing for doing that. The AES output was what I was really after. It's a real-time sample by sample. What you heard in the video was a direct feed into the camera through an AES receiver circuitry that I also designed and constructed for the Make It challenge. So this is the backbone of what this project is, really. There's other elements to it. We're going to get to those. The touch part of it is important as well. That's something that he touches on, no pun intended, in this write-up. But the main thing here is you have powerful digital signal processing happening on board and then data output happening. This is where we move on to the new hardware. Just as we scroll down to the newer iteration, or what the newer iteration will be based on, I'd like to point out that the write-up itself is wonderful, but it also links out to important things. For example, I had missed the fact that he'd linked to the Wikipedia article of AES3. I could have saved myself the time of trying to pull it out of my head, and also linked here to what balanced lines are. So this is a balanced line output will give you a lower noise floor. If you'd like to know why, the Wikipedia article is fantastic about it. The AES3 article, after a quick glance, I don't think I got it all that wrong. It can carry 2 channels of PCM audio over balanced, unbalanced lines or fiber. I haven't checked if the thing I said about speed was right or wrong yet, and I'm not going to in case I was wrong. Now, there's a great blog here about the IMX RT600 Audio EVK, which brings us perfectly onto the real meat of the challenge here. He's going to be bringing this thing up to speed, and he's going to need 2 things. As mentioned before, we need onboard DSP, and we need data output. For the onboard DSP, he's going to be using a new part that he's created a wonderful little dev kit for. Dev kit, dev board, whatever you want to call it. The NXP i.MX RT685. And as it says here, it combines a 300 MHz Cortex M33 core with a 600 MHz Tensilica Hi-Fi 4 DSP. A very powerful MCU and a very powerful digital signal processing IC on the side as a co-processor is the perfect thing for a project like this. So we have a powerful MCU, we have a powerful DSP unit, we have a way of getting audio in and changing that audio into a digital signal and then doing what we want with that digital signal. Now previously that was sending it out over a Cat6 cable either as audio through the DAC or as just digital audio data. which brings us on to one of the inspirations for this project. Now, I just want to point out at this moment, this mock-up for the guitar is very beautiful. The mock-up really is just a mock-up. This project is about the hardware bring-up and the reasons behind choosing the hardware that he has. But yeah, I'm very excited by the blinking lights on that. Also, we don't go into it today. He doesn't go into it in this project yet. It's for a future part of the project. This entire pickguard could well be a touch sensor. The original one had an iPod touch kind of wheel here. He points out in a line somewhere in this project that we now hold amazing capacitive touch devices in our pocket absolutely every day, and it's true. The gesture-based input of smartphones is wonderful, and incorporating something like that into the pickguard might be very cool. But why have such amazing DSP on board and then pair it with something that is capable of sending large amounts of data with a low power overhead? Well, to actually find the answer to that, Eli turns to old synthesizers and sampling keyboards and workstation keyboards of the past. And it makes me so happy to see that he's talking about this because, yeah, for example, he mentioned somewhere in here the ASR10. So many hip-hop classics were made on that sampler. It's incredible. One of De La Soul's biggest tunes with MF Doom was made on that sampler, and so for someone like me, the fact that he's referring to this in it is just a buzz in and of itself. It's so rare that like hip-hop and the embedded things come together like that. Anyway, getting slightly sidetracked. One of the things that this synthesizer, and also many arranger keyboards, have in common is that it has an always-on circular buffer, which means that it remembers what you did for the last X amount of time, regardless of what that was. You can just be playing around, messing around, making sounds with patches, and if you did something like 30 seconds earlier that you thought, oh, okay, that was fantastic, what was that? You can literally wind back through, and it has been recording everything you do just in real time and keeping it for you. And Eli wants to bring that concept to playing the guitar. And this is where the nRF7002 comes in. So the samplers of old would save all of the data on board so you could spool back through it, either on board on a chip or via a floppy disk. But things have come on a long way since then. We now have cloud storage, huge amounts of it, and it is incredibly cheap. And digital audio data, the raw data itself, isn't particularly large. So you have this amazing onboard system that could save everything the guitar player has played in a session on board, and then you have a way of sending this to the cloud. And why would you want to keep all of that data? Well, you can find something that you played a week ago. So, okay, in a session I was playing with the guys 2 weeks ago, I did one riff that was amazing and it fitted perfectly at the time, but I cannot remember exactly what I did. You can just go to your database of all the things you've played, find the timestamp that fits that session, and then hear it played back because it's a digital signal processing chain. It'll take that raw audio data and play it back exactly as it was at the time. That is incredibly powerful. And I hope you appreciate why I said at the start of the show that we were probably going to spend much of this show talking about it. We've been talking about this one project for several minutes, and I've tried to be relatively brief, and yet it's taken us this long to even get to the point of why the Actiuve Pickguard is going in this direction, and why this particular NXP part and this particular Nordic part can come together to make something really quite special and something that's never been done before. An ongoing database of everything a guitarist has ever played that can be played back exactly as it was played in the moment. Now, having given an introduction to all of this, I have not forgotten that we are in the middle of running a competition to give away one of these nRF7002 EK headers, the Arduino shields. And so before going any further, just to break this up a little bit, before we dive into how the hardware came up of this and how the Zephyr project is central to this project, let's talk about the nRF7002 EK and of course announce the winner of the contest. So, the 7002 is going to be central to the project we've just been talking about. But what is it? Well, as I've talked about many times, it is a Wi-Fi 6 IC. It is Nordic's first Wi-Fi part. It is Wi-Fi 6, which brings you a lot of functionality for a very low power cost. If you'd like to find out more, Robin, as always, will give you a much better description of it than I will. Robin is an engineer. He actually understands this stuff on a level that I probably never will. And you can find that out from the video and from the write-up, which is linked in the description. We also started a competition on our last show to actually win one of these Arduino headers, and it is time to announce the winner of that contest. And the winner is Stefan Kirsten7501, who says, I will add Wi-Fi to my Roomba school project, which is such a cool idea. And Stefan, when you do that, please do write it up and put it on the Electromaker website. I would love to talk about that project on a future show. Good luck with putting it together. It sounds like a really wonderful idea. And of course, as I mentioned, I don't really understand it all that well, but I do understand that if you wanted to add Wi-Fi to a project that uses batteries, Wi-Fi 6 is probably going to be the best bang for your buck in terms of very low power usage. But yes, I'm very excited to see what you end up doing with that. But that is not all. That is not the only contest that we're having on this week's show. We do have another contest, and it is for yet another thing that I'm actually quite a fan of. Yes, it brings me a lot of pleasure to finally give away this blues kit. And when I say a lot of pleasure, I mean a lot of pleasure because for once I don't have to give mine away. I get to keep mine and play with mine more. I have some blues content coming up in the new year because as you probably saw if you read my review, I did a very long review which went slightly over the amount of words I was even asked to write. And I really got under the hood and played with this a bit and had a lot of fun with it. I really like the workflow with the blues note card. And as I said, for someone like me who is not an embedded engineer, who has not got a history in this, it was just such a breath of fresh air to have a really clear way of learning everything from their tutorial right up to how to get really down to the weeds and even construct your own methods for sending the JSON commands out to the board. It's just a very flexible way of working. Now, I'm not going to wax lyrical once again about it because it is time for me to pass that on to Robin. As I've said several times, it's really good that we have Robin because he is an actual engineer and an educator. He knows what he's talking about, and he is also going to be talking about the blues note card in our product of the week. This time round, the product of the week is just a video because I'd already written this massive review up. But if you would like to find Robin's video, you can find a link to it in the description of this video, or of course, you can find it on our YouTube channel alongside all the Electromaker show videos. I ran out of words there for a moment. Sorry, it's been a very long couple of weeks. However, this being the Electromaker show, you know what is coming now. This is a giveaway, and if you want to win it, all you need to do is be subscribed to our YouTube channel. It's open to all of our subscribers, and all you need to do is leave us a little comment saying what you would do if you won the Wi-Fi and cellular note card kit. And it's as simple as that. You need to leave the hashtag note card as well, NOTECARD, no spaces, note card. And we will pick a winner on the next show that we put out, which may be in the new year, so maybe this contest will run for a little bit longer than our usual contests do. But that just means hopefully we'll get more entrants, and I hope we do, because I hope I've impressed upon you how cool I find this thing. If you're looking for something which makes Wi-Fi and cellular connectivity easy, if you're looking for a cloud service that isn't too difficult to get your head around and that is free unless you're using a lot of data and things back and forward, sending a lot of notes, you're going to have a lot of fun with it. So yes, that competition is going to run until the Electromaker show comes back, which may be just after Christmas, or it might be in January, when we will be announcing the winner. So let's jump back over to Eli's project. Where we left off, we'd already talked about what he wanted the guitar to do, which is basically take in the actual analog audio, do whatever digital signal processing to it needs to be, and store it all as digital data, either to then immediately pump out through the DAC or through the AES-3 protocol to play live in that moment, or just to save that digital data so that it can be banked later via the nRF7002, uploading it via Wi-Fi, right? So you have everything that guitar has ever played, just like the old composer keyboards of the past, just like the old samplers of the past that had that circular buffer. The difference being, instead of a circular buffer that overwrites itself after a certain while, it all gets pumped up to the cloud and you have a database of everything you've ever played. It's a wonderful idea. But how do you get bleeding edge hardware like the nRF7002 to talk to a completely new development board that you've just made yourself? Well, the answer to that is the Zephyr RTOS. So, the Zephyr project is part of the Linux Foundation, and it does actually borrow a few ideas from Linux. It is an RTOS, and until recently I just knew Zephyr as Zephyr RTOS. I didn't really realize the scale of what it was. Whereas Free RTOS is a fantastic real-time operating system with a task schedule and everything you need. There's nothing wrong with Free RTOS, but that's just the real-time operating system element. So you have your real-time operating system, and let's say you're using an STM32 chip. Maybe you'll use libraries like libopencm3, which work with the STM32 and a few other similar boards, but you have your RTOS and then you have your host libraries and everything you need to build it all together, and you're working with just one piece of hardware. Zephyr is more like a framework that will allow you to switch out sensors and hardware at will without having to change all that much code. And I do understand that framework is a bit of a dirty word for embedded engineers, but it's the closest thing that I can come to thinking about it. And to give you a sort of example, I want to tell you what I did last week, very briefly. We're not going to look at much in the way of code. We're not going to explain everything. In the future, hopefully, there'll be an Ian Explains video where I can go into detail about the very basics of how to get started with Zephyr and the RTOS. Truth be told, I've hardly touched the real-time operating system element of it because the other stuff is actually so much more interesting to me. But for me, what it started out with was my laptop downstairs and my computer upstairs and 2 different development boards. So it's very rare that I would say something like this, but this is one of the few times I would say, if you really are interested in understanding why I'm excited about Zephyr, stop watching this video at this moment and go and watch Eli's talk on Zephyr, or go and watch an introduction to Zephyr online. A more recent one would be better. There are introductory videos to Zephyr that are 7 or 8 years old, but a lot has changed since then. And there are a myriad of YouTubers, some of whom I'm going to talk about in just a minute, who give some great content on Zephyr. And to really understand it, I would suggest going and watching a full-length video. I would love to make one. One of my things that I have pegged for the new year is a full-length video on why Zephyr is, for me, what I'm going to learn and what I want to base my project on. But if I had to give a elevator pitch like now, here is our fantastic development board that we have made in-house. This is our development board. It might look like an Arduino Nano BLE 33 cents, but shh, this is my fantastic board that I put sensors on that are connected via a combination of SPI and I2C. It has user buttons, it has LEDs, it has a BLE chip, lots of nice things. And over here is the code that me and a bunch of different developers in our studio have been working on for this board. And everything's working swimmingly, it's great. Now, we've just realized that we're not going to be able to get this sensor anymore. We have to use a different sensor. So that means all of this code is going to have to be changed. Swapping that out is going to be a bit of a mess. If only there was something in between the code and the board itself, which meant that we wouldn't have to change the code to vendor-specific code whenever something on the board changes. That's what Zephyr is. Zephyr is not just a real-time operating system, it is a hardware abstraction layer that abstracts in a way that allows you to switch out any part of the hardware from the chip itself through to any of the sensors without having to change any of your code. You just have to change the descriptors that link the code to the board. So code over here, board over here, you have your device tree and your kconfig in between. The device tree says to the code what the board has, and the kconfig says to the board what it does on boot up in order to speak to the code. I hope I said that correctly. Zephyr developers, please roast me in the comments if I got that wrong. So I could spend time telling you about West, which is Zephyr's all-in-one package manager, does everything. It's sort of the NPM of Zephyr, although I'm sure that will enrage both embedded developers and web developers if I compare those two things. But West can do everything from grab the relevant code from GitHub for your project, down to configure your project for you based on things that you may have worked out beforehand. You can give it a manifest file that can set things up for you in a certain way. That is also a fantastic way of sharing different versions of code with different people on your team. Again, this is not really the point, because I'm not going to be making much use of that as a solo noob who's trying to learn this off his own back. What I'd like to do is learn the API, learn the RTOS, and with that in mind, I had my Arduino Nano BLE 33 cents up here as a board that supports Zephyr, and I have a Raspberry Pi Pico downstairs. Both of these have been added to the Zephyr project by the community, by the way. That isn't to say that the big names aren't part of it. NXP and Nordic have really gone full bore, and Nordics especially are really behind the Zephyr project. They're very deeply involved with it, and if you look at all of the code examples for their newer parts, they pretty much all reference Zephyr because they are very deeply involved with it. They are a platinum member of Zephyr, if I have that correct. Apologies if I have that wrong. People from Zephyr and Nordic, please don't kill me. Now, I wanted to follow this tutorial. I believe the one that I was trying to follow at the time was this Maxim Drakov tutorial, the Zephyr RTOS tutorial, which just basically is nice steps, goes through getting set up with it, the RTOS basics, threads, GPIO, all of that kind of stuff. But I ran into a problem very quickly, and that is the Zephyr kernel here. Here's the sleep time, print K, which is their thread-safe version of print F, and it says, okay, yeah, the basic sample loop, it loops and it stops, and so it spits out over the serial port every 1 second, basic sample loop, and you can listen to that on Minicom or whatever. I quickly discovered that both the Arduino Nano BLE 33 cents and the Raspberry Pi Pico W do not have that set up as standard when you flash this to the board, right? And so I thought, okay, well, I need to go through and find the right header and turn all that on and do all of that kind of stuff. And that is when Mr. Green stepped in. This is the other YouTube channel I was talking about, Mr. Green's workshop. His Let's Run Zephyr RTOS on Raspberry Pi Pico, one of these episodes goes through how you can use the device tree and kconfig. You can overlay onto the device tree and the kconfig in order to turn different things on. So when you set this up to build, when you actually say, okay, West build for this board name, it will go into that board. It will get all of the hardware, all of the hardware identifiers from that board and all of the configuration from that board, and put it together into the correct places for the linker scripts and everything to build it, and then put it onto the board. But if you know you want certain things set up ahead of time, you can do things like set up overlays. So the USB overlay here, if this does not make any sense to you, do not worry, it still barely makes any sense to me. But this is part of the device tree that gets put on top of the main device tree for the ARM architecture inside the chip, and then the specific chip itself, and then it steps up the ladder and up the ladder. So every single board that is based on the same ARM Cortex chip as the nRF52840 starts with that base device tree descriptor, and then it steps up and up and up until you get to the very board that you're working on. And yes, if you have a custom board, you can make your own custom device tree overlay in order to get that going. You don't have to start from scratch. And all this is doing is adding to the overlay that I want to use CDC ACM UART0. Yes, I want to use my USB port as my serial port. And it says, okay, that's how the hardware is going to interact with the code. When you print over the serial, that's how it's going to work. And then all I needed to do after that was add to my configuration files. Do I want to configure the USB device stack? Yes. This is the name of the product. This is the product ID. This is the vendor ID. Do we want to initialize this at boot? And the serial port, the console, all of this kind of stuff. These are all just different configs that you set into the builder. And then you can go back into the main file, and there's no extra code here. You include the Zephyr kernel, you say print K, and because you've set it up ahead of time, it knows to print over the serial port. And the great thing about it is it prints over the serial port using this Nordic chip on this Arduino board, and exactly the same process got my Raspberry Pi Pico talking over the serial code on a different OS on a different board. I mean, same architecture, yes, they're both ARM chips, but fundamentally different things. I hope that my enthusiasm but bad words has given you a very small idea as to why I think that's powerful. Now, I hope I didn't lose too many of you in my terrible description of Zephyr, but this brings us back to the project. So we started by talking about the original idea. We started by talking about the guitar. We started by talking where it was going next with this new Super Monkey board, which has all of the power, and the nRF7002 EK, which has all of the communication. And this is where Zephyr steps in. And this is one of the reasons why Eli was so keen on using Zephyr. As you're seeing here, one of the things he liked is that it has a Zephyr first approach to the software integration of the nRF7002. It also has a quad SPI interface for the hardware, and a good balance of power consumption and performance. We talked about all of this before. And this is where the project gets really interesting, because it now is talking about getting the nRF7002 up off the ground and how we got it talking to the NXP chip. And I want to make it very clear, this isn't just incredible from the point of view of someone like me who does not know what they're talking about. I have it on good authority that even Nordic's engineers are very interested in speaking to Eli about how he's done this, because this is so very bleeding edge. But I can say one thing for sure, and I'm almost certain Eli would agree with me when I say this. The reason that this is possible is because of Zephyr. The reason that you're able to take a bleeding edge piece of hardware and attach it to a completely new board like this is that he's able to describe how all of this hardware works within an API that is designed for switching out hardware and making things talk to each other. But yes, he starts off by using the nRF7002 DK, again, something we talked about in the past. This is the development kit we talked about way back in the day at Embedded World, which has the nRF7002 IC on it. It also has an nRF5340. I get so confused. The 52840 is the letter of 5340, I believe, which was at the time their flagship chip. I mean, Nordic has now announced the nRF54 series, but this is still the sort of flagship chip you can get on one of their development boards. And this is in fact that development board. I've been messing around with the 5340 dev board again because of Zephyr. If you would like to know more about it and Zephyr, Goliath, who are an IoT cloud service that are very deep in the Zephyr ecosystem as well, do training on it and actually use the nRF7002 development kit from that. I'll say nothing more about it other than there's a link in the description if you'd like to know more about it. And the rest of this project is Eli's attempt to get everything up and running, starting with absolute basics. How do you speak to the nRF7002? How do you get it talking to Wi-Fi? How do you speak to the IC from the host MCU? And then how do you speak to the IC from your own host MCU? And that is what's happening here. So, having taken the nRF7002 DK, which is the slightly larger version of the full development kit, and just kind of basically learnt the ropes, he then moves on to the EK and into incorporating it into his project. At this point, I would like to mention, I haven't really done the whole subscribe to us on YouTube or shop in our shop thing today. It's been a very busy show and hasn't really been time for it. I would mention, if you're interested in this EK, we have it in our store right now. It is only $20. That's electromaker.io/shop. Financially supporting us this way is, well, the only way to financially support us. We don't run any adverts or anything like that. So if you would like to try and emulate the incredible things that Eli has done in this project with the EK, do consider buying it from us. Anyway, the EK has a few examples. Nordic has examples that use Zephyr. And if I make this as large as I possibly can, we can look at what's happening here. So there's a few examples here. And this is West, as I mentioned. This is Zephyr's all-in-one build system and everything system. But in this particular instance, it's building it, and you say build, and you pass B to pass the name of the board. And so the nRF, this bottom line is the really interesting one, actually. The nRF9160 DK, the nRF9160 is their cellular and Wi-Fi chip. It's the one found in the Thingy 91. They also have a separate DK for it. But here's the interesting stuff. They have an overlay configuration file here, and also they're naming the shield for the EK. Now, all of this is the same stuff I was talking about before. Those configuration files are going to be talking about how the hardware and how the boot up software side of things will be working to talk to that shield. And that is what he's going to use in order to make it work with the NXP board that he's created. And this is sort of the point. This is what this whole episode has more or less been leading up to. But it seems like such a dry thing on the surface that I needed to give you all of that context in order to make it as exciting as it really is. Because by looking at the overlay of it itself, so this is the shield overlay that was passed here in the West build. It passes the shield overlay there. And in the shield overlay, you see, oh, okay, it uses this thing called Arduino Spy. And inside there's an Arduino header reference that talks about some GPIO pins. Oh, okay, right. So underneath all of that, you look at that and you find, okay, the Spy spec is just talking to a thing called Spy, not Nordic's Spy, not the Spy specifically on the nRF5340, just Spy. And so it's all the way down, it's talking just in absolute general terms, and all you need to do is make Spy talk to your particular bit of hardware. None of the code samples have to change, none of it has to change at all, just the configuration for the board itself has to change, and that's what happens next. I should make clear at this point, actually, Zephyr has made this a lot easier, but this is still an incredible achievement, and I think there are some elements of this which are absolutely bleeding edge, and Eli is doing wonderful things. I just realized I'm making it sound so much like Zephyr's doing all the hard work, and it's not. Eli is doing this. But the way that Zephyr works is facilitating it, and it is sort of amazing. So, moving on to the actual hardware in question, the i.MX RT685. This is the EVK version of the same chip that's on his little Super Monkey board we looked at a while ago, and of course the EK fits on it because it has an Arduino header. And this development kit is A, completely supported by Zephyr, and B, has the same Arduino Spy and Arduino header in its Devicetree. And what you're seeing here is one of the real powerful parts of it. You can see Arduino Spy here and Arduino header, and then in the overlay for the N7002 EK, and if you remember, overlay is what you can do to add to a Devicetree, to add functionality to something. He is taking a reference to the Arduino Spy and adding this nRF7002 to it. So it's got all the same code, it's doing all the same stuff, it's basically saying all the same things, but it doesn't really care what hardware is underneath it because it's all described in this same Devicetree. All that work has already been done for you. These things speak the same language as each other, and all you're doing is adding these specifics on top of it. And you're doing that in configuration rather than code. Now, there are many other wonderful things that happen before this particular part of the project comes to an end, and I'm going to leave those for you to discover yourself. For example, getting Wi-Fi working fully. It was only, the example only had Wi-Fi scanning working. He wanted to get it working as in a full Wi-Fi supplicant mode, yeah, he had to find a pull request that hasn't actually gone into the main Git stream in order to get that working. He also has a fantastic thing here on his Super Monkey SoC hardware. The SuperMonkey is exactly the same thing that we've just been talking about earlier. His wonderful, nice little board. Both of these links out here are absolutely worth reading. This is the SuperMonkey itself and the hardware around it, and this is how to create a custom Zephyr board for it. This is, again, all the same things we've been talking about, how you can create your own device tree, your own kconfig. If you start going down the Zephyr rabbit hole, you'll find yourself reading a lot of this stuff, not understanding much of it, but the little bit you do understand will get you very excited. I absolutely appreciate that this show has been very different, and I'm sorry if it's been a bit of a slog for some of you, but this project was something that we couldn't just leave alone. It combines so many things that I find fascinating, and having just gone down the Zephyr rabbit hole, having spent so much time talking about the 7002 EK, and the fact that this is a music project just grabbed me in so many ways, and I really wanted to try and do it justice. I hope I have. And Eli, if you see this and you have any further comments, please feel free to use my comment section as an open book and talk to people. Maybe we can talk about this when you're ready to talk about maybe the next part of it. Maybe have enough of an understanding of Zephyr to come back to it and we can discuss this project in detail, because I really do love it. But yes, as you can see, getting this hardware working with this IC is now something that is happening. He's able to connect to the internet with it, and this means he has a super powerful MCU with super powerful DSP and a way of transmitting huge amounts of data with a low power footprint. He's pretty much getting ready to get started, and before you know it, there's going to be a rather beautiful new version of this guitar. I just want to get back to this. If we're going to end with one thing, we have to end on the blinking lights, don't we? That was our show for this week. Thank you so much for joining me, and thank you for your continued support, whether that is just clicking like here on YouTube or making sure that you're subscribed to our channel, or supporting us financially at electromaker.io/shop. Just a reminder that the nRF7002 expansion kit that you've seen in today's show is available on that store along with the rest of Nordic's line of products. All of Arduino's, Raspberry Pi's products. We stock everything from Adafruit and Sparkfun as well. So yeah, if you're looking for anything for your project, consider looking at our website. That is the best way to financially support what we do here on the Electromaker show and all the other things that we're doing on the Electromaker channel. This episode was a little bit different. There was one thing that I looked at from several angles, and I'd be very interested to hear what you thought of that. If it's the kind of thing that you like, it's something that I could consider doing maybe once every few Electromaker shows, because it's the same idea, really. We're still looking at projects, and we're still looking at products, and we're still looking at the way things work and explaining things, but it's all focused around one theme. Of course, Eli made it very easy for me because this is music on microcontrollers and digital signal processing, things that I'm very passionate about, and then Zephyr, which I'm getting into, and of course Nordic's stuff, which we would be talking about anyway because we're in the middle of a giveaway, all fitted together very nicely. But if you'd like to have other things like that, other project ideas that you want me to explain from various angles, do let me know in the comment section. I'm certainly open to trying it. Anyway, I should end this show before this outro risks being longer than the show itself. Thank you all so much for your support. I will chat to you very soon. I hope you have a safe, fun and creative week. Bye bye.